In this video, we're going to look at factoring trinomials of a very specific form. So they should look like x squared plus bx plus c. We're going to start by looking at a pair of binomials, x plus 2 times x plus 3. Now, we could multiply these two binomials out. We could multiply them together, and we will get a polynomial expression. These two binomials will be factors of that expression because that's the relationship between factors and a product. So if two things multiply to get that product, or in this case that polynomial expression, that's the product, then those two things that multiplied have to be factors of it. So let's go ahead and FOIL it and see what we get. So we get x squared times x and 3 is 3x, 2 times x is 2x, and 2 times 3 is 6. And simplifying, I get x squared plus 5x plus 6. Well, what that means is that x plus 2 times x plus 3 is the factored form of x squared plus 5x plus 6. So what we're going to be doing is factoring polynomials that look like this, and here's b and here's c. These numbers can be other things, but we're going to be factoring expressions that look like this into pairs of binomials. So if you have a trinomial of the form x squared plus bx plus c, we might be able to factor it with this following method. Find two numbers that multiply to c and add to b. If we can do that, then the factors of that trinomial are x plus number 1 that multiply to c and add to b, and x plus the second number, which I'll just call number 2 for now. And that's a little theoretical, but I'm going to show you that method in action right now. So here's an example. We're going to factor x squared plus 11x plus 24. And as a reminder, 11 is in the b spot and 24 is in the c spot. So we want to find two numbers that multiply to c and add to b. And so I always start by writing out c. I do this off to the right-hand side of my page, kind of out of the way. And then I just start listing factors of 24, pairs of factors, and I'll see if they could add to b. Well, for 24, I could start with 1 and 24. Those multiply to 24. But do they add to b, to 11? No. So another pair would be 2 and 12. They add to 14, which is closer, but still not right. Another pair is 3 and 8. Oh, well, look at that. 3 times 8 is 24, and 3 plus 8 is 11. So these are my pairs of numbers, 3 and 8. So now I write, to factor it, x plus the first number, which is 3, and x plus the second number, which is 8. And this should be my factored answer. However, it's always good to check. And we're going to check with FOIL. So I'm going to multiply back out what I just factored, because it's really easy to make mistakes in this process. So now we just FOIL out what we got, and we get x squared plus 8x plus 3x plus 24. And you can see how we're reverse engineering FOIL when we factor trinomials. Here's why we need two numbers that multiply to 24, because 3 and 8 multiply to that last term c, or 24. And 8x plus 3x also equal 11x. So that's why we need those two numbers to add to 11. And so we've checked our work. If we FOIL out our factoring, we get the original. And so we have factored correctly. So in this next example, the only thing that's different is that our terms are out of order. So it's really, really important that our terms are in the order x squared plus bx plus c. So all we have to do here is rearrange our terms to be in that proper order. And now we're ready to begin the same process. So x squared plus 2x minus 48. So this minus is part of c. So c here is minus 48. So I need two numbers that multiply to negative 48 and add to plus 2. That would be the b. So negative 48, what are some factors of negative 48? Or what are two numbers that multiply to negative 48? Well, we could try 1 and negative 48, or negative 1 and positive 48, but obviously those aren't going to add to 2. So thinking about what I could divide 48 by, I think I could divide it by 4. So let me check in my calculator. 48 divided by 4, oh, I get 12. So I could try 4 and 12. And if I put the negative sign over there, that still doesn't work. I still don't get them to add to plus 2. So let's try another one. Can 48 be divided by 8? Oh, yeah, it can be. 48 divided by 8 is 6. I should know that from my times tables. So let's try 6 and 8. Well, if I put a negative sign on the smaller number, so I have negative 6 times 8, I get negative 48, and I also get numbers that add to 2. So I can factor x minus 6 and x plus 8. You can write those brackets in either order, so you could write x plus 8 times x minus 6. That would be fine too, but that's how I'll write my answer. And then again, we should always check. And so I'm going to check using FOIL. I get x squared plus 8x minus 6x minus 48, and that gets me my original expression. So it works. Another example here. These ones are in the right order, so I can jump right to the method, which is two numbers that multiply to negative 9 and add to negative 8. Well, I could try to start with 1 and 9, and actually I think this pair is going to work for me. So if I need 1 and 9, I need to put the negative somewhere, and I need to get negative 8. So I'm going to go with plus 1 and negative 9. Those ones should work for me. Those add to negative 8 and multiply to negative 9. So my expression will be r plus 1 and r minus 9. And now I'm going to go ahead and check. So multiplying those out, I would get r squared minus 9r plus r minus 9. And simplifying, I get my original expression. So check mark. This one I did correctly. And here's one last example I wanted to show you. So looking at this, our terms are in the right order, so let's go ahead and start factoring or looking for pairs of numbers. So I need two numbers that multiply to plus 5 and add to negative 30. Well, first of all, 5 is a prime number, so the only numbers I could use are 1 and 5. And they need to multiply to plus 5, but add to negative 30. Well, I guess I could put negative signs on both of them, but those are only going to add to negative 6. So this one actually can't factor. This one cannot be factored. So factoring trinomials really relies on the fact that on the hope that we can find a pair of numbers that multiply to C and add to B. But it's not going to be true of just any expression, and you could come up with lots of expressions yourself that are not factorable, at least by this method. So just a heads up that you could see those out there, but again, the ones that you're usually going to see in this course are going to be factorable.